Um, we use the absolute value in algebra to measure distance. So, thinking back into your awesome geometry days last year, yeah, it was awesome, wasn't it? The distance from zero on a number line is what we call the absolute value. Now, can I have a negative distance? Yes. How can I have a negative distance? Can't. And you're saying I can't, right, Asher? Huh. I never thought of that. Huh. That's interesting. I'll have to do some thinking on that. I'm thinking 3 dimensional, not so much 2 dimensional up and down, but maybe a third dimension. If you were walking, let's say this is the school here. Okay, here's school. I'll put a point where school is. Say your home is over here, -4. If you walk from your home to the school, how many units are you walking? For whatever the unit is, if it's 4 miles, 4 blocks, or whatever. So we're not going -4? Why not? What if I'm at school and I'm going home? Still 4. Huh? -4? So are you, what, walking backwards? No? Just you're walking -4. So are you, so if you're walking home backwards, it's negative. No. Um, unless you got a time machine, um, you can't walk negative units, right? Yeah. No matter which direction you're going, right? So say this is I don't know, Beefaroo over here. If you're at school and go to lunch, you walk to Beefaroo, and you walk from Beefaroo back. You're not going a negative distance, right? You're going 4 units one way, 4 units the other. Yeah, that's the essence of absolute value bars. Okay, anything that's inside of these absolute value bars has to be come out a positive. Now, just because your home's sitting over here at -4 and the school is at 0 and Beefaroo here is at +4, it's more of a like a location point, right? Your home happens to be over here, Beefaroo happens to be there, and school there. That I kind of I call them location points. Now, there's really no term in mathematics. It's kind of something I made up. This is where you're located, but the actual units that you go from one location to the other is a positive distance, and that's where um, absolute values come into play. So when we solve an absolute value equation, and somebody tells you, "Well, I went 4 blocks to school. Okay, I walked 4 blocks to school." Do you know whether you're at the +4 here or the -4? You don't. Right? It's 4 units that you went. So, in every absolute value equation, we have to consider both of these locations. And that's why you have two problems in every absolute value equation because you have to consider both of these points. Okay, so what you do is you take what's inside and you split it up. Okay, you go, well, this could equal the 2x minus 5, can equal the opposite of what they're negative 9, or you take what's inside and it can equal the number that's there, that's given to you. So with absolute value equations, like I said, you always have two problems to solve. Well, the first thing I'm going to do is add 5 to both sides. And I get 2x equals negative 4. Divide by 2. And x is going to equal negative 2. Now, it's okay for x to equal a negative number because, again, that's just a location point. That's not the distance. You're just kind of figuring out what those location points are. Let's go ahead and do the other one. Let's add 5 to both sides. I get 2x equal 14. Divide by 2. What's that?
You did it on the other side.
Yeah, they set it up over here, but that's okay. And my x's cancel. I get x equals 7. So my answer here is x equals negative 2 or x equals 7. We're not going to always, in fact, hardly ever do we have x equal lines for you to fill in. You're going to be doing it this way. So let's go ahead and do some example problems. Um, Obviously, equations are a lot easier than tomorrow's lesson, the inequalities. Okay, so just kind of get you prepped for tomorrow's lecture. All right, number one, in order to drop my absolute value signs, I got to take what's inside, set it equal to the opposite. Now, I like putting my negatives over here on the left hand side. So I take x plus 3, set it equal to the opposite of 5, or x plus 3, set it equal to what's there. And then solve each one of them.
That's what we're going to be doing.
Yeah, that's what you're going to be doing today. So, like I said, my other class, most students finished the worksheet, didn't have any homework. So I'm going to solve for x. Going to subtract 3 from both sides. I get x equals negative 8, or subtract 3 from both sides. And I get x equal 2. Number 2, I'm going to take what's inside, set it equal 7t plus 3 equals, again, I put my negative numbers first. You don't have to. Take what's inside, 7t plus 3 equal positive 4. Solve for x, or t. Subtract 3. Subtract 3. I get 7t equals negative 7. divide by 7, and I get t equal -1, or subtract 3, 7t equals 1, divide by 7, and here I'm going to get a fraction. T equals 1/7. So here's my answer.
You're going way too fast.
Huh?
You're going way too fast.
Oh, I'm sorry.
No.
I'm sorry.
That's just a problem.
Am I going too fast, guys?
No.
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 A couple. I still see a couple of students taking writing. So yeah, I'll slow down a little bit.
No, I apologize.
Okay, number 3. I have a little bit of a problem. I have this number being multiplied to my absolute value. So I need to isolate the absolute value bars before I can split it up. Okay. So I need to multiply. What's the easy? Think of that as a coefficient. What's the easiest way to get rid of a fractional coefficient? Yeah, divide by 2/3 or multiply by its reciprocal, right? So I get my absolute value bars, 1 plus 2x equal, well, let's see, that's over 1, 2's cancel, and I get 3. Now that my absolute value bars are by themselves, I can go ahead and split this up. Let's see, I take what's inside, 1 plus 2x, set it equal to the opposite of what's there, or take what's inside, 1 plus 2x, and keep that positive 3. Go ahead and solve for x. See, I'm going to subtract 1. I get 2x, -3 minus 1, -4, divide by the coefficient 2, and I get x equal -2, or solve the other side. See, I'm going to subtract 1. I get 2x equal 2. Divide by the coefficient 2. So on this side, x is going to equal 1. So there's my answer. Now, number 4's got those little asterisks, those stars, right? Means there's something going to be going on with this. So let's keep an eye out for what's going to happen. All right, first of all, I need to isolate the absolute value bars. So I'm going to subtract 5 from both sides. And I get the absolute value of 2 minus 4x is going to equal 3 minus 5, -2. Okay, so I did one step. Let's think about this because there's asterisks there. Are we okay to go? Did I do everything right? Should we keep going? Yeah?
No.
No? Why not?
Yeah. At 3 to be a positive or negative 3.
Say that again?
At 3 to be a positive or negative
When we're doing absolute, I think I know what you're saying. When we're dealing with absolute value symbols, what's the definition again?
3. Essentially even, no negative or positive.
Yeah, it's a distance, right? It's a distance from zero. We already know that it's always going to be a positive number. Now, when we drop those absolute value symbols, like in our previous problems where we drop the absolute value symbols and we do two problems, we're considering both cases. Now, these were working for the location points, but the actual absolute value is still a distance. Can this ever happen? Can the distance be a -2? Anything that comes out of the absolute values, no matter what we plug in for x, can never equal -2, right? In other words, the distance of -2 is 2 units. The distance of +2 is 2 units. Just because I have two terms here, the distance can never be negative. I mean, a lot of students will make the mistake and split this up, but if you're looking at absolute value bars and it's isolated by itself and it's equal to a negative number, there's no solution to this. Because anything that comes out of absolute values is positive. Yeah, I right down there that there's no solution.
I guess.
Okay. Yes.
Theoretically, why wouldn't you be able to break it down right as it is?
Well, we could. I mean, you want to try it? Let's let let's just see what happens. Okay, 2 minus 4x.
No, I meant from like the actual problem. Like the absolute value 2 minus 4x plus 5 equals 3.
Because anything that comes out of here, eh, you can't. You've got to isolate this, okay, before you can consider both location points before you can solve it. All right, just for the heck of it, let's go ahead and try to solve this. 2 minus 4x equals the opposite of what's there. So it'd be +2. Or 2 minus 4x equal -2. Let's go ahead and subtract 2 from both sides. Get -4x equals 0. So anything, we divide 0 by anything, it's going to be 0. So x equals 0. Subtract 2 from both sides. I get -4x equals 1. Divide by -4. This time, I do get a number here. Zero is a number, but a number other than one is negative 1/4.
You are to divide -2 minus -2 is -4.
Oh, I'm sorry. Yeah, I should have. Yep, you're right. Um, I should have divided. Let's see. I missed a step, didn't I? I screwed this up. Should be negative 4x equals -4, right? And then x equal 1. Sorry. So, just for the heck of it, so you really don't know at this point. You got x equals 0, x equal 1. It looks like a normal problem, right? It doesn't look like you did anything wrong unless you're like me and screwed this up. Well, let's check it. Let's go back into the original problem. Okay. So I've got the absolute value of 2 minus 4x plus 5 equal 3. And I think, Asher, this might answer your question. So let's plug 0 in first. So I'm going to plug in 0 for this. So 2 minus 0 is 2. The absolute value of 2 is just 2. And if I add 5 to it, does that equal 3? No, so this doesn't work. Let's try 1. Okay. Absolute value of 2 minus 4 times 1. Does that equal 3? Well, here I have 2 minus 4 is negative 2. The absolute value of negative 2 is 2. So this doesn't work either, right?
What I did is I basically times divided by 2 and negative x. Then I added 3 to the 12. So
There is no solution to this.
oh,
No matter what I plug in for x, there is no way, because it's going to come out positive number, right? No matter what I plug in for x, anything out of this absolute value is going to be positive. And then Asher, I'm going to add 5 to that, right? So any positive number plus 5 is not going to equal 3.
oh, I thought you were on problem 5.
Oh, no. I was going back and
Oh, that's
sorry.
what I was talking about.
I didn't realize that. My fault. Does that make sense? That's why when we got to this point, I knew there was no solution because anything coming out of here is positive plus 5 will never equal 3. All right. I guess I took the long way to explain that. I hope I didn't confuse you too bad.